So we have quite a bit to do today. If it logs out, then make sure you go back in. I'm very sorry. Realize that you guys, as long as you're logging on and you're getting on your Zooms and stuff like that, you're getting your attendance. If you need to take a little bit more time, remember you have a long weekend. So if I push a lot on you these next 2 days, then don't stress out. Okay. Don't you can turn it in a little bit late. So just like Haley was saying, she was struggling. Y'all have time, especially in my class. So if it has to be pushed back a little bit, that's fine, because there's nothing that's really, right now, it's not really building on itself. It's different things each time we talk. So just because you don't do today's don't mean that you're not going to get tomorrow's or whatever. So if you want to wait till all of 1.3 is completed and do all of your 1.3 homework, that's fine. I don't mind that. So do whatever you need to do to alleviate your stress, because that's the worst thing we can do is have that much stress. Okay. So again, do what works for you. And that's the good thing with online learning, is that you can do it when it's comfortable for you. So just don't get too far behind waiting. There are a few of you who are waiting too long to do assignments and you're about to get absences because you're not logging on. You need to make sure you get those turned in, because you don't want to come back to school, if we do, with multiple absences already and then get sick or something happen. Okay. So again, make sure that you're logging on and you're doing your work. So we're going to start reviewing. The first thing that we're going to do is review this stem plot data. So I'm going to just go ahead and make this. I think everybody is okay. If you're not okay with making them, let me know and we'll talk about it. So we go from 5 to 60. So I'm going to go from 0 to 6 on my stem. Remember, when you do your leaves, you put them in order. So the only single digit is 5. And then you try to line them up. And then we look at our ones. We have 15, 10, 12, 10, 10, 10. So there are 4 10s, so there should be 4 zeros. There's a 12 and a 15. Remember, again, put them in numerical order. Then we have our 2s. We have 20, 25, 20. So 2 zeros and a 5. And then we have 2 30s. So we'll just put 2 zeros here. And then we have 2 40s. We don't have any 50s, and we have a 60. Okay. So again,
I'm a little confused about like the key part of it.
The what? The key? Yeah. So if we made a key for this, we would pick any number in here. So like 3 0 represents 30, and then you just put what it represents. So this was travel times in minutes. 30 minutes of travel time.
And you don't have to do that for every number, right?
No, just for one of them, just so it knows.
Okay.
All right. So then we're going to start talking about how to find measures of center. So the first thing that we're going to talk about is the mean. The most common measure of center is the ordinary arithmetic average. You guys know how to take an average or a mean. So this is called X bar. So mean, and then in parentheses, X bar. And again, that's just the symbol for mean. Yes, you do need to know that, okay? X bar is the sum of the observations. I can't write. Over N. N is the number of observations. Okay. I've yet to put your formulas on Canvas. I need to do that. I'll do that today. I'll make myself a note right now. Formulas. So you guys can see them. You won't need them for this first test. You eventually will. But this formula is on there, and it looks like this. This is summation. So if you've taken calc, I don't know if pre-calc has it yet. So that just means add them all up. So this means sum. Sum all of the x's then divide them by the number of observations. Okay, so on your formula sheet, that's the formula you would see. Most people don't remember what that means. They just remember how to find the mean. Okay. Tell me if I go too fast. Like I said, we got a lot to do today, and I don't want to give you a whole bunch of work or anything like that.
When's our test gonna be?
It's in Canvas, whatever day it is, because I keep pushing it back. So it was supposed to be like tomorrow or Friday, but I've pushed it back. It may even end up being pushed back more to like Friday of next week. Okay, so whatever you see, I don't think I can go any later than Friday of next week. We should finish these notes. Hopefully by tomorrow we should finish these notes. If we don't, we don't. Okay, so I'm not trying to super rush it, but at the same time, I do want to get them done. Okay, all right. The sigma, that's what it is. It's actually a sigma in the formula for the mean. It's short for add them all up. The subscripts on the observation, so that little I right there, are just a way of keeping the N observations distinct. They do not necessarily indicate order or any other special facts about the data. So that just means I stands for individual. So like if you had 3, you would add the first X, the second X, and then the third X. So that I is just a general way to say that. Okay. Actually, in the notation, X bar refers to the mean of a sample. Eventually, you will need to know that as well. It may not be for this test, but it will be for a test eventually. Most of the time, the data we'll encounter can be thought of as a sample from a larger population. When we need to refer to a population, we'll use the symbol mu, and it's like a curly M. If you have the entire population data available, then you calculate mu in the same way. Add all the values and divide by the number. Okay, so it's the same. So population and sample mean right now is going to be the same. It's just not going to be the same number. Okay, same way to work it out. All right. So it says, here's a stem plot of the travel times. That's what we just made on the front. Here's that key that we were talking about. I didn't make mine as specific. I was just trying to go over it really quick. You want to make it as specific as possible. I don't think it'll kill you not to. All right. So it wants us to find the mean of all the workers. So how would we do that?
Add them all up and divide by the total.
So we would do 5 plus 4 10s plus 12 plus 15 plus 2 20s plus a 25 plus 2 30s plus 2 40s plus a 60. Add all those up. And then how many workers was it?
15.
Divided by 15. I'm gonna go ahead and tell you that that's 22.5. I do not expect you to do this by hand at all. Please don't think that I'm gonna make you do that. You can put the data in your calculator, and I will show you in just a second how to do that.
Can I see the bottom of the notes that you just scrolled down past?
This?
Yeah, that's good. I just took a photo so I can write it down because I don't have it printed.
No worries. Remember, I record it so you can get that, and I scan them in too. Okay. Calculate the mean again, this time excluding the person who reported a 60-minute travel time to work. And what did you notice? So all they want us to do is cancel out this one. No, I'm not going to do it. What I'm going to tell you is that your new X bar will be 19.8 minutes. So what happened?
The mean decreased
Yeah, why did it decrease?
because you took away that larger value.
So if I have a larger value, my mean increases. So that larger value pulls my mean to the high end, if that makes sense. So if I add another large value, that mean will increase. If I add a smaller value, that mean will decrease. So this is the point that you're trying to make in this. The mean is not resistant to outliers. And the mean is pulled toward those outliers. Okay.
I have a question about the test. Are we going to have a review before it?
Yes, that's also in Canvas. The review's not done. Remember, I told you the review will be done. I go through whatever test I choose because I have multiple test banks right now. And you guys, I don't want to give you like a 4-hour test or anything crazy. So I'm probably going to modify it again. I haven't even looked at that yet. I'm going to tonight. This is my night off from kids taking them everywhere. So I will pick out what I want for the test, and in the review, I'll literally go through your notes and give you like a cheat sheet. These are the things you should know. Okay, so don't stress too much. All right. The previous example illustrates an important weakness of the mean as a measure of center. The mean is sensitive to the influence of extreme observations. It's the same thing that we just said. So the mean will be pulled towards the outliers or those extreme observations. Now, I keep saying that because they may not be outliers, so they could be, but when we have a skewed distribution that has no outliers, it will also pull the mean towards the tail. Okay? Because the mean cannot resist the influence of extreme observations, we say that it is not a resistant measure of center. All right. So center is the average. Now we're going to talk about median. And remember, I taught you how to make the median by lining them up and crossing out till you got to the middle. You already knew how to do that. You've done that for years. In section 1.2, we introduced the median as an informal measure of center that describes the midpoint of a distribution. Now it's time to offer an official rule for calculating the median. All right, so the median, half the observations in a data set are smaller than the median, half are larger. Okay, half the observations are smaller and half are larger than the median. So how did I tell you to find the median again?
Cross them out.
But what do I have to do first?
Line up. And then
Yeah, order least to greatest. If it's odd, you're going to take the middle number. If even, you're going to average the two middle numbers. Okay, and again, you guys know how to do that. Medians require little arithmetic, so they are easy to find by hand for small sets of data. You wouldn't want to do it for like 100 cars. Arranging even a moderate number of values in order is tedious, however, so finding the median by hand for larger sets of data is unpleasant. So you don't want to do the median for large sets. All right, that's all we're writing on that page. We're gonna flip to the next one. Find the median when it's odd. So if you look, they were really nice to you and they did it in order. So 5 to 20 and then 20 to 60. So to find it, cross out high low, high low, high to low, high low, high low, high low, high low. Your median is 20. All right. Are you guys okay if we don't make a stem plot on the next one?
Yeah.
Okay, so what they want you to do to make the stem plot for is to put it in order. Okay, but we're gonna do it by hand. We're not gonna do a stem plot, okay? So what's the smallest number?
5.
Mm-hmm. What comes next?
10.
10.
And there are 2 of those, just to let you know, 10 and 10. What comes next?
15.
There are 4 of those. Correct me if I'm wrong. 1, 2, 3, 4. What comes next?
20.
There are 3 of those. I'm gonna start a new line. What comes next?
30.
We got it one more time.
Oh, 25.
25. That's all right. What comes next?
30.
There's 2 of those. Comes next is 2 40s, a 45, 2 60s, a 65, and an 85. Again, we don't have to do these by hand, but we're gonna do them right now just in our notes, but I won't make you do it in your homework. I'll show you how to do it on the calculator. So we're gonna mark out high and low, 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 high and low. Same thing again, again. And what's left is 25 and 20. So when you have 2 left, add them, divide by 2. You're going to average them. So this gives us 45 divided by 2, which is
22.
22.5. And that's all on that page. Okay. Any questions? I think we're doing pretty good. All right. Our discussion of travel times to work in North Carolina illustrates an important difference between the mean and the median. The median travel time, which is the midpoint of the distribution, is 20 minutes. The mean travel time is higher at 22.5 minutes. The mean is pulled towards the right tail of this right skewed distribution. Okay, so just to throw this out here, I'm going to draw it really little up here. This would be a right skewed distribution. Your midpoint would fall more in the center. And because your tail is on this side, your mean would fall this way. It is pulled towards the tail, okay? Your midpoint is going to stay the same. If we change that 60 to a 70, we're still crossing out that 70 at the same time that we're crossing out the 60. So that doesn't change it at all. But if we average a 70 in, then it's going to pull it up higher. So that's what it's saying. The median, unlike the mean, is resistant. If the longest travel time were 600 minutes rather than 60 minutes, the mean would increase to more than 58 minutes, but the median would not change. Okay. I'll give you a second to do that and listen to what I'm saying. All right, so if we go back to this data that we just had right here, and we average it, if we change this 85 to a 90, so let's say we change it to a 90, it's gonna pull the average up. Just like if you got a 90 on a grade instead of 85, the 90 is gonna pull your average higher to the 90, okay? But if we still do the midpoint, we're still crossing it out at the same time that we're crossing out the 85. It does not change these two numbers' values. So that's why the median is resistant and the mean is not. The outlier just counts as one observation above the center, no matter how far above the center it lies. The mean uses the actual value of each observation, and so will chase a single large observation upward. All right, so this part right here, you're gonna need to know. I'm telling you right now. Okay, so know this. So everybody got all the writing at the top. I'm gonna move it up so we can have this just plain. All right, so if we had a normal or roughly symmetric graph, that looks like this. Remember, we talked about the mean being at the peak. So is the median. So if it's roughly symmetric, the mean and the median should be very comparable, very close. If it's a perfect normal, they should be the same. All right. If it's right skewed, your median will still be at the hump, just like I told you, but then your mean will be pulled towards the tail. So tell me about these values. How does the median and the mean compare just in value? Which one's bigger?
The median is bigger.
The mean.
Oh.
Think about a number line. If this was a number line, this might be at 0 and this is at 5.
Yeah, I was thinking of the y-axis.
It's okay. All right, so then if we have a left skew, and it looks like this, this would be your median. That would be your mean. And how do they compare?
The median is bigger.
The median is greater than the mean. You could also say the mean is less than the median. It doesn't matter as long as it's that way. All right. So you need to know those figures. You need to know that deal right there. It will not show the figures. What it will do is ask you, if it is right skewed, how does the mean compare to the median? If it is left skewed, how does the mean compare to the median? When should I use mean and when should I use median? So the problem is, guys, what happens when you use mean on right skew?
It gets really high.
Or it gets
Really small.
really small. So it's pulled away from the data. Does everybody understand that? So we only want to use the mean with roughly symmetric or normal. So now when we go back and do shape, center, spread, outliers, when we do our shape, if it says roughly symmetrical or normal, our center will always describe the mean. Okay, so that's how you justify which one you use. You've been asking me, that's exactly how you do it. So when it's not, when it's skewed, we're going to use the median. It's a better judge of the data and it's not influenced by the outliers. All right, again, shape, center, spread. When we're talking about center, I got about 10 minutes left because we talked before. When it talked about center, we want to use the mean if it's roughly symmetric, median if it's skewed. Okay. All right, check your understanding. Here, once again, is the stem plot of those times. The median, remember, was 22.5 minutes. So I'm going to write that up here so you guys can see it when I move it. All right, so that's all that one says. Based only on the stem plot, would you expect the mean travel time to be less than, about the same as, or larger? So I told you this is exactly how they're going to ask. So the first thing you need to ask is, what shape is this? What shape is this? We already talked about it.
Is it roughly symmetric?
What do we say about this one? We've already talked about the shape. Does it look roughly symmetric?
It's right.
No.
Right, skewed.
Yes, we have an
I'm
outline.
having a hard time telling.
Yeah, I'm about to explain it.
I'm having a hard time telling what shape it is.
Yeah, I'll tell you what it is. So our data is heavy at 0. So like if I turn it, let me do it with this thing, the other way. If I turn it sideways like this, oh, it's all backwards, sorry. And I'm looking at my 0. You see what I'm saying? From 0
Yeah.
to 8, all of my data is on the low end, and I have an outlier, a possible outlier here. So that means I have a hump over here and a tail at the end. You see it?
Oh, okay. I got you.
All right.
Yeah.
The tail is on the high end. The high end of a number line is on the right. So this one is skewed right. So remember that looks like this. Sorry, I don't know why that's got that weird hump there. Something like this. So where would our mean be compared to our median? So is the mean time less than, the same as, or larger than the median?
It's gonna be larger than the median.
And sometimes I have to literally draw it out. So that's why I drew it for you, that I know that this is going to be the median. So the mean has to be towards the tail, which means it's going to be greater on the number line. And that's it. Okay, it says use your calculator to find the mean travel time. Was your answer to question 1 correct? So to find that, I don't know where my calculator went. You put all your values into L1, L2. Now I have values in mine, and I'm just going to use those values. There's not a lot, just to show you. So I have just 3 numbers. All right. You're going to go to stat. We edit first. So first is stat and edit. Put all your values in. Then you're going to go back to stat, over to calc, and you're going to do number 1, which is 1 bar stats. Okay. When you hit enter, it should say L1. That's where we put it in. We don't care about the frequency list, and we're going to calculate. See how it pulls all this out? This X bar was what we were looking for. That's your mean. If you scroll down a little bit, your median is right here. So that's literally all you do, but for time's sake, I'm not going to make you put it in there, but no, this is how you do it.
Which one was the mean?
The very top one, X bar.
Okay, I didn't see it. Can you
It's
scroll?
okay. No, it's okay. And then it really says median for median. Okay. So for this one, the calculator will tell you that the median is 22.5 and that the mean was 31.5. So were we correct? Is the mean greater than the median?
Yes.
Yeah.
And that's it. Which one is better to use for the summary of the center?
Median.
Why?
Because it's skewed.
Good. And why do we use
So
median?
use median.
But why? Because it's skewed, but why? What's special about the median? It's what?
At the peak.
It's the R word. It's resistant to outliers. You need to know that.
So use median when it's skewed and use mean when it's symmetric.
Yes.
I'm so confused.
Why?
Okay, that's right.
Yeah.
I don't know. Is that right? Did I say that right? Okay, gotcha.
Girl, you're doing good. All right. Well, I'm trying to get my pages apart. They're not coming apart. I have about 4 minutes. And what we may do is just go ahead and stop where we're at, and then I'll revamp everything again. So don't take your quiz for today yet. I will put it up within 10 minutes. So I'm not even really giving you homework today, okay? I'm not really giving you homework today. It'll be a different quiz, and I'll move this one down. I'll readjust everything, and then we'll go from there, okay? So let's get through maybe this page we're going to try. So
We don't do quiz 8.
No. If you have it done, just hang on to it because it'll happen, okay? But it's just not going to have to happen today. And that'll give you a chance to get some time done. If you want to start it, you can, but it's not due today. So a measure of center alone can be misleading. I will put a different quiz up for today, and trust me, you will like it, okay? So just, you got to trust me. The mean annual temperature in San Francisco, California is 57 degrees, the same as in Springfield, Missouri. But the wardrobe needed to live in these two cities is very different. That's because daily temperatures vary a lot more in Springfield. A useful numerical description requires both center and spread. The simplest measure of variability is the range. We've been doing the range because that was easy to find and we didn't know anything else. So if it stretched, your lowest was 1 and your highest was 4. Okay. To compute the range, subtract the largest and smallest values. This will show the full spread of the values, including, that includes outliers. Again, I have about 2 minutes, so if it turns off, we'll come back in, but we're only finishing this page, okay? We can improve our description of spread by also looking at the spread of the middle half of the data. Here's the idea. This is part of the 5-number summary. You did that in Math 1. So Q1, median, Q2, max and min. The other two,
Never learned that stuff.
well, you'll learn it now. We're doing it. It's called the first quartile and the third quartile. All right, has everybody got that much?
Yeah.
I'm going to go ahead and stop the share. And I'm going to end this meeting. I'm going to stop recording.